Hello, my name is Covadonga Alvarez and I am project manager of the joint venture between IDESA and Windar, two companies of the Daniel Alonso Group based here in Avilés, in the region of Asturias, north coast of Spain. IDESA Windar joint venture is in charge of the supply, manufacturing and delivery of the 66 transition pieces for the Merkur offshore wind farm, which is located in the German North Sea. We're now in the port of Avilés. It is 3 kilometers away from IDESA and Windar workshops, where the main bodies of the transition pieces were manufactured. And here took place the last part of the manufacturing process: appending of the pieces, mechanical assembly of all parts, electrical installation, and final coating touch-up works. Here behind me, you can see a batch of those transition pieces already completed, ready to be loaded in the transport vessel. But we'll see that later. First of all, what is a transition piece? A transition piece is part of the foundation where the offshore wind energy converters are mounted. This foundation consists of two parts. One is the monopile that is driven into the seabed, and the other one is a transition piece. It is located on top of the monopile and acts, as the name suggests, as a transition between the monopile and the tower of the converter. They are located, therefore, partly submerged under the sea level and partly above it in the splash zone. This is why corrosion protection of these structures is extremely critical. As you can see, the color of their top coat is bright yellow. This is for two reasons: to allow a good visibility once they are placed in the sea, and also to protect the structure from the sun radiation. The main body of the tipi is a cylinder that is 6 meters wide and has 24 meters height, and it's made of rolled steel plate up to 90 millimeters thick. It has several appurtenances attached to it. On the outside we have the boat landing, these two vertical fenders where the boats will rest when they access the pieces offshore. In the middle, the rest platform, then the access ladder that goes up to the external working platform. Inside we have flange bolting platform, a level below is the E-module, and farther down is the airtight deck. All these pieces have been manufactured and coated in workshops of this region and the adjacent ones. Having a reliable and experienced supply chain was one of the key factors of the success of this project. The overall weight of one of these structures is 330 tons. Okay, we're going to get closer to one of the pieces and go inside. My colleagues Gustavo and Diego are waiting for us there. Let's put our harness on and meet them.
Hello, my name is Gustavo. We are on the top of the TP in the external working platform. To access to this level, we need to climb up the boat landing and the access ladder. Here, around me, we have different elements. This is a transport light, the handrail, the grating, that is the floor. This is the GPS. This is a normal light to illuminate all the area in the external working platform. This is a navigation light. This is a reflector. It's only a temporary element in order to help to the vessel installation in the wind farm. Here we have two lifting lugs in order to help to the crane to handling the TP. Here we have the TP cover to protect the TP against water ingress. In the wind farm we need to remove both lifting lugs and TP cover in order to install here the tower. The bottom flange of the tower will be joined by bolts to the top flange of the TP. Here we have two cranes, a temporary crane and the pal finger crane. From this level we can go inside the TP, and the first level we will find is the flange bolting platform. So let's go inside.
Hi, I am Diego Lopez and we are inside the TP, in the airtight deck, the lowest platform. This platform is shipped inside the TP but these supports are temporary. Later, when the TP will be installed in the monopile, this platform will rest in a support attached to the monopile, fixed by 96 clamps. The gasket placed at the bottom of the platform will make this area airtight and isolated from the seawater. At this level, we can see the bottom flange that is bolted to the monopile flange. The manufacturing tolerances of millimeters for these flanges were one of the greatest challenges during manufacturing. The sea level is still some meters below of the deck, therefore the space, the area between the deck and the sea level shall be ventilated in order to avoid accumulation of gases. This ventilation is done through two ventilation pipes that starts here, go up to the TP till the very top and open to the outside. Finally, the medium voltage cables coming from the tower go through these openings and down inside the pile till the mud line. From there, go to the substation carrying the power generated by the converters. Now we will go to P1 in order to continue the visit. Now we are in the E module, in the middle level of the TP. This module consists in two platforms, P1 and P2, and is bolted to supports welded to the TP wall. Here we have cabinets and is the control area of all systems. Here in P1 we have different cabinets. Here the CMS system or condition monitoring system that provides useful information about the structural behavior to maintenance and engineering teams. Here, the ICCP system cabinet that provides corrosion protection to the entire structure. There are 4 anodes and also internal anodes, all of them connected to this cabinet. Here, the marking lights cabinet. And finally, the low voltage distribution cabinet that provides power to all auxiliary systems of the TP. Now we are continuing the visit with P2. Now we are in P2. This platform is dedicated for the switchgear cabinet. The switchgear connects and disconnects the wind energy converter from the substation if necessary. Here we are just below of the flash bolting platform. The flash bolting platform is used during the tower installation onto the TP. Also is the first personal access coming from the tower or the external working platform.
Hello! In our scope is as well the transport of the transition pieces from the port of Avilés to Eemshaven in the Netherlands. This is the base harbor where the pieces will be loaded into the jack-up installation vessel that will bring them to their location in the wind farm. We are now inside the transport vessel, the Roldok Sea, a heavy lift where a batch of TPs is now being loaded. These TPs are loaded using the ship-owned cranes in batches of maximum 8 TPs. They are transported in the vertical position, and to allow this, a dedicated grillage has been designed, manufactured, and welded to the vessel hull where we are standing. The way the TPs are fixed is by means of their shipping flange that is attached to the grillage by clamps all around. This fastening system is checked periodically by the vessel crew along the trip that will take about 3-4 days depending on the weather. Okay, and now we've seen a TP from the outside, from the inside, from top to bottom. And this is it. We just have to wait till the complete batch is loaded in, secured, and the only thing left will be to wish them a nice and safe trip to Eemshaven and further to their final location in the Merkur offshore wind farm. Bye!